So looking at page 55 in the Unit 3 packet, a couple of word problems related to these central limit theorem type questions. A machine that puts the center holes in blank CDs operates in such a way that the distribution of the diameter of the holes may be approximated by a normal distribution with a mean of 1.5 and a standard deviation of 0.1. We have consistency with the units, so that's a good thing. Just be careful about that. Sometimes, it'll say 1.5 centimeters, and then it'll say 0.1 millimeters or something like that. All right, so 0.1. Specifications require that the diameters of the holes to be between 1.4 and 1.6 centimeters. A CD not meeting the specifications is considered defective. All right, a little explanation of what that would mean. What proportion of CDs produced by this machine are defective due to an improperly sized center hole? All right, so they need to be between, so must be between 1.4 and 1.6 centimeters. Now, we can handle this a couple of ways. All right, one way to handle it would be to figure out the proportion of CDs that are, or in which the holes are smaller than 1.4. We could say probability that X is less than 1.4, or quality 1. Or we could say greater than 1.6. All right. So that's one possible way of handling it. The other alternative, we could say it would be 1 minus, so I'll write same as, the probability that the X values are between 1.4 and 1.6. Same as 1, I forgot my 1 minus. You can go with it either way. The benefit of doing it the way I just wrote it in red is that it's one computation. Well, 1.5 computations. All right, so it would be a normal distribution. Either way, we would need to come up with z-scores. All right, so we would need z of 1.4 and z of 1.6. Now, you may be wondering, well, is this a central limit theorem question? The answer is no, because we didn't sample from the population. All right, we're just looking for the probability in general that basically any CD selected at random would be outside of these parameters. Now, if it said 14 CDs were selected at random and the mean and standard deviation were found to be this and that would be a different story. But that's not the case here. Essentially, they didn't give us an n value. Right? That's your key indicator. So we're finding 1.4 minus 1.5 over 0.1. And then we're doing the same thing, 1.6 minus 1.5 over 0.1. All right, now this is one of those really nice instances where things just kind of work out, all right, cleanly, because 1.4 minus 1.5 is negative 0.1, divided by 0.1 is negative 1, positive 1 on the other end. So if we figure out 1 minus the probability that z is between negative 1 and 1, we'll have our answer. Now, you could actually go with the empirical rule in the instance where between one standard deviation about the mean is about 68% of the data, but we have the calculator to do it for us, so why not? All right, from negative 1 to 1, that's the 0.682. Now, if I want to do a subtraction, oops, put it in the wrong place. What I can do is take this number, 1 minus 0.682689 492,137. So it's about 0.317. All right, but let me get this value in here. So 0.682689, 492,137. It's going to round to about 0.317. All right. So with a mean and standard deviation for the population of 1.5 and 0.1, there's actually over a 30% chance that you're going to get a defective item. That's probably not good. You know, I'm not in the business of making CDs, you know, physically, or content-wise either. But I can't imagine that's a good number. That's like almost 1 out of every 3 of them are going to be bad. I don't like the sound of that. All right. But a conclusion can be drawn. Now, in number 5, a plane used to fly tourists in and out of the rainforest contains seating for 16 passengers. The total weight limit for the passengers is 2,500 pounds, assuming the average weight of the tourists is 150 pounds, the standard deviation 27 pounds, and that the distribution of tourist weights is approximately normal. If the weight limit is exceeded, the plane has difficulty taking off safely. If a random sample of 16 tourists has booked a flight, what is the chance that the weight limit will be exceeded? All right, so another instance where it's a normal distribution, it's just a question of how are we going to tackle this. Well, they told us that they gave us a total weight limit, but they said the average weight of the tourist is 150 pounds. So mu is equal to 150. Sigma is 27. They told us that the n value is 16. All right. So if we want, and there's a couple of ways we could do this. There is a way that we can do it using a normal distribution, but if we wanted to use central limit theorem, a way of handling this would be to say, well, what would be the maximum per passenger weight? All right. And for that, it would be just a quick 2,500 divided by 16. All right. So on average, weight cannot exceed 156.25 pounds per person. All right. So we could use that piece of information, and that accounts for the n. All right. So if I want to know the probability that the plane will be able to take off safely, I could say the probability that the average weight is greater than 156.25. All right. I'm sorry. The weight limit is exceeded, then the plane will have difficulty taking off safely. So we're looking to determine under what circumstances the plane will not take off safely, which would be x bar greater than 156.25. All right. So we're looking for the z-score corresponding with that 156.25 minus the mean of the group divided by the standard deviation of 27 over the square root of 16. All right, so I'm going to crunch those numbers. On the low bound, so if we're looking at a graph, we would be imagining that this is the low side of the graph. So let me get a fraction bar in there. 156.25 minus 150 over 27 divided by the square root of 16. We're looking at about 0.926. So the z-score would have to be more than 0.926 in order for this plane to not be able to lift safely off the ground. All right, and so what I can do is, that's my minimum, get this over to a maximum, get it to converge on a particular number, and we'd be looking at a probability of about 0.177. All right, so based off of these parameters for these individuals, we're looking at almost a 20% chance that the the plane's not going to take off safely. So that's dangerous.